good morning. Today we're going to continue with differential equations. So let's take a look at the first response question number 1. At the beginning of 2010, a landfill contains 1,400 tons of solid waste. The increasing function, the function W is increasing, model a total amount of solid waste stored at the landfill. Planner estimated that W will satisfy the differential equation dW dt equal to this for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. Use a line tangent to the graph of W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010. So time equal to 1/4 because 3 months out of 12 months is 1/4. So part A, so basically we need to do tangent line approximation. At t equal to 0, and the function is w of t because the graph of the w. So now after that we're going to approximate w of 1/4. So let's find y equal to mx plus b or mt plus b because it's t instead of x. It doesn't matter if you just use x. So now we know that t equal to 0. So y equal to w of 0 at the same time. So what is w is 0? Let's take a look at the beginning of the question. It says over here there are 1,400 tons. So we get the 0 comma 1,400. I mean we need to use m because it's to this function, okay, to the graph of w. So we had to use w prime of 0. So we find dw dt at t equal to 0. So now let's take a look at the equation. So we had dw dt equal 1/25, and then we get w minus 300 at t equal to 0. But this is not a function of t. We had 1/25 in parentheses w minus 300. W, but we already know that this is t comma w. So t equals 0, w is 1,400. So that means we just substitute 1,400 into w. So now we just have to calculate. So from here you can do it by hand or use a calculator. So when you are taking your AP exam, don't forget to bring a calculator. You're allowed to use calculator. So now I am going to do it by hand. So I'm going to make it 11 times 100 because I know 25 can go into 100 by 4 times. So I get 44. So now I get my m equal to 44. So y equal to mt plus b or mx plus b. So the beginning point we have 1,400, m is 44, and the time is 0, and then plus b. So now we got 1,400 equal to b. So the tangent line is y equal m 44 times t m plus b. Next we're going to approximate w of 1/4. So w 1/4 equal to 44 times 1/4 and plus this. So we just simplify it. So we got 11 plus 1400. So we got 1411. So our approximation is about 1,411 tons. So we finished part A. So let's take a look at part B. Part B. Find the second derivative in term of W. So it had to be in term of W. Use the second derivative to determine whether your answer in part A, my answer in part A is 1411, is an underestimate or an overestimate of the amount of solid waste that the landfill contains at t equal to 1/4. So here, there are two things you have to find. Number one, you have to find the second derivative, and then use the second derivative to determine whether the answer is going to be under semi or over semi. So we put out all this together. We get 1411 from tangent line approximation. And we learned that if you have a curve that is concave up, okay, your tangent line is going to be under the curve. If the curve is concave up, the tangent line is below the curve. Then the approximation is underestimate. So for example, okay, we don't know how the W look like. So if this is the W, okay, so this T equal to 0, then T equal to 1, 4 should be on the right side, okay, and then 1, 4, 1, 1. So this is 1, 4, comma 1, 4, 1, 1, and this is the WT. So definitely the 1, 4, 1, 1 is below the actual value if the curve is concave up. So if the curve is concave down, the tangent line is above the curve. Then the approximation is overestimate. Okay, at this moment we don't know how the W look like, so it could look like this. Okay, this or this, we don't know. So if, okay, for example, if this is a WT that is concave down and this T equal to 0, then the tangent line look like this, and then here it's going to be 1, 4, comma 1, 4, 1, 1. So if WT is concave down, then your 1, 4, 1, 1 will be bigger than the actual value. That will be overestimate. So this is the idea of all behind this question. So in order to figure out the graph is going to be concave up or concave down, we have to use the second derivative. So we viewed that before. If the second derivative is positive, the curve is concave up. If the second derivative is negative, the curve is concave down. That is why we need to determine the sign of the second derivative. Okay, so now we're going to figure out the sign of the second derivative. Now let's take a look at the third derivative first. Okay, so we get dw dt equal to 1/25. You got w minus 300. This is a number, so I decided to multiply it out. If this is a variable, I would use product rule. Because this is a number 1/25, I decided not to use product rule. I am going to multiply it out. So I'm going to get 1/25 w minus 300/25. If you want, you can simplify it. Now I'm going to find the second derivative. 1/25 stay the same. The derivative of w is w prime. And the derivative of this is going to be 0. So I simplify it. And then I am going to get 1/25 times w prime. However, I cannot leave my answer this way because the answer had to be in terms of w. Okay, so I'm going to substitute. Okay, so this is going to be 1/25 times w minus 300. Okay, So now I'm going to simplify a little bit. I'm going to get rid of this set of parentheses. And then my second derivative is going to be 1 over 25 squared, or 625, b25, 25, 625, times w minus 300. Okay, so I finished finding my second derivative. In a moment, I'm going to determine the sign. So let's go back over here in case some people said they don't like this way. So you get dw dt equal to 1 over 25 w minus 300 over 25. So the second derivative, so 1 over 25 stay the same because you're going to take the derivative of the w and the function of time, so therefore it should be dw dt. And then my 0. And we are not allowed to leave our answer this way, so I'm going to substitute this by the 1 over 25 times the w minus 300. We substitute it, this one. We substitute it. And then we're going to simplify a little bit. So you got 625 and okay. So these two are the same. So you just choose the method you like. I'm going to stick with my first column. So now I'm going to determine the sign of this. This, you have w minus 300. We definitely know this is positive. All we need to do is figure out is w minus 300 is positive or negative. So the only point that we know is 0, 1,400. And then let's go back to the beginning, see if we get any more information. Okay, so let's read the question one more time. At the beginning of 2010, a landfill contains 1,400 tons of solid waste. The increasing function W. Okay, the hint is right here. Increasing function. Okay, so because WT is increasing. Okay, so that means at t equal to 0 is 1,400. And then WT, it definitely would be bigger than or equal to 1,500 for or T. Because increasing, you already begin with 1,400. So based on this, W minus 300 is positive. And then the second derivative is positive for all time. Then the curve of WT is concave up. The tangent line we found in part A is below the curve of WT. So the approximation in part A is an underestimate. So we finished question part B. Now let's go to part C. Find a particular solution W equal WT to the differential equation with the initial condition W0 equal to 1,400. So we get dW dt equal to 1 over 25. And you get W minus 300. And the initial condition is this. So the question asks us to find the WT. So we have to separate the variable. Okay, step number 1, separate the variables. In this case, only W and T. I have a W over here. It cannot be here if you multiply the dt to this side. So we get dw equal to 1/25. Okay, so we multiply the dt, and I still had w minus 300 over here. So I need to eliminate this. So next step, I have to divide this. So after I divide this, so this cancel out, so you get 1/25 dt. And here I'm going to rewrite into 1/w minus 300 and dw. Now we're going to use integral. Okay, if you have watched a video before, so now it looks familiar already. So over on the right side, you have a number. So I put 1/25 times t instead of x because it's a t, and plus c. And over here, I am going to have w minus 300 to the -1 dw. So some people probably already see this is going to use ln. If you can skip step, you can go ahead to skip step. I'm going to make u equal to w minus 300 du equal to dw minus 0. dw and du are the same. So now I don't need to multiply anything. Okay, so I'm going to just change a variable. W minus 300 equals u, so u to the -1. dw is du. And now we know that this is going to be 1/u. So the entire derivative of this. Okay, so you have to memorize this formula. So now I'm going to get absolute value of u. Okay. Now u is w minus 300, so ln w minus 300. So we learned that before. In order to undo ln, we have to use e. So I'm going to put e as a base for both sides. So this cancel out. So I got absolute value of w minus 300. And this is going to be e to the exponent 1/25 t plus c. This becomes the exponent. Now let's take care of the right side over here. So make it e to the 1/25 t times e to the c. So same base, addition. We just go backward. If you go this way, same base, add the exponent. When you go backward, okay, you make a same base in multiplication. So now I am going to make this equal k. Okay. So now I'm going to go back to the left side. I have absolute value. So to get rid of the absolute value, so I am going to put plus minus. Okay. So I want to solve for w. So I plus 300 both sides. So I get w equal to plus minus k e to the 1/25 t plus 300. So we get our general solution. So to find our particular solution, we have to use the given information w is 0 equal to 1,400. This is positive, so therefore I'm going to use the positive branch. And then you get 0 for t and then 1400 for w. Okay, now we just solve for k. E to 0 is 1. So we found k equal to 1100. So now the particular solution, okay, w equal to, so over here we got k is 1100, and then you put e to the 1 over 25t, and then plus 200. So we finished. So this is going to be our particular solution. So we finished question number 1. So you need to go to video number 2 to take a look at question number 2.